Hello everyone, a very good evening all of you and a very warm welcome to you all to this beautiful session on thermal engineering. Please guys do join me fast, and those who are already here, please do respond me through the comment section if my audio and visual quality are fine. So please settle down fast because we are going to discuss only 10 questions from the various corners of thermal engineering, including the application of the thermal engineering. So basic thermodynamics and its application will be discussed today in the form of numerical practice. So keep your pen, notebook and calculator handy and try to solve as many questions as possible on your own. Hi Pradeep, good evening, welcome, how are you? So shall we start? If my audio and visual quality are fine, please do let me know. Those who are watching me live, respond through the comment section. Before I start my session, let me quickly introduce myself. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi. I have also cleared engineering services examination which is conducted by UPSC. I have worked in Steel Authority of India Limited for a couple of years, as well as I have worked in a private consulting firm for more than 2 years. So my total industry experience is more than 4 years, and the rest of my experience is into teaching. That is more than 10 years of teaching experience I have been having, and I am guiding the students from last 10 years for the various competitive examination. Hi Maniket, good evening, welcome. So these are my favorite subjects: fluid mechanics, heat transfer, thermal, as well as industrial engineering. If you have anything to discuss, any doubt in any of the subjects, you can always connect with me through the mail ID, or you can join me on the Telegram, which is Mechanical by Chandrasekhar. Either you can use the link mentioned at the bottom, or you can scan the QR code, or you can search by the name Mechanical by Chandrasekhar to be part of my Telegram channel. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalam Walaikum, Wanakam. Please guys get yourself settled down and try to interact with me as much as possible. Try to ask your doubts as well as try to share your knowledge through the comment section. As you all know, Engineering Services 2023 results had already been announced recently, and we feel very proud to say that BYJU'S exam prep students had done or have achieved the brilliant results with the hard work of the students as well as with the guidance of the teachers over here. So these are some of the highlighted ranks or the top ranks which BYJU'S students had secured. So let us start with the question number 1 directly without any delay. First of all, do let me know, read the question first and try to let me know the procedure to solve this question. Which is the topic from which this question is framed and how to solve it. Let us read the question, everyone. Let us try to read and understand the question, and then we will solve it. And meanwhile, you can start solving it. And if you have any doubt, then you can let me know through the comment section. The thermometric property X. What is a thermometric property? Thermometric property is a property of a substance which is used to measure the temperature directly or indirectly. Of a thermometer varies with temperature. The thermometric property X varies with temperature T according to the relation T is equal to AX square plus B, where T is in degree Celsius, X is in centimeter, and A and B are some random constants. At the ice point, that is 0 degrees Celsius, and steam point, that is 100 degrees Celsius, the values of X are 5 centimeter and 20 centimeter respectively. At the temperature 0 degrees Celsius, the value of X, thermometric property X, is 5 centimeter, and at the value of T is equal to 100 degrees Celsius, the thermometric property X will be 20 centimeter. With this thermometer, when this thermometer is brought in contact with the heated body, the value of X is recorded as 15 centimeter. What will be the corresponding temperature of the heated body? How to solve it? The question is from the 0th law of thermodynamics. Very simple question, though it is little lengthy, but you should know the method to solve it. The first step is to obtain the value of A and B, isn't it? Two conditions, two unknowns. From the two conditions we can get the two unknowns, and we can get the two equations, and these two unknowns can be solved by using those two equations. Once you get the value of A and B, then put the value of X as 15, you will get the value of T corresponding to X. Hi Kiran, good evening, welcome. इतना जल्दी कैसे solve किया Kiran? Have you already solved this question? So at T is equal to 0, X will be equal to at T is equal to 0, X will be equal to 5 centimeter. We can get one equation. So 0 is equal to A into 5 square plus B, or we can say 25A plus B is equal to 0. That is equation number 1. The second equation we can get at T is equal to 100, X will be equal to 20 centimeter. Put the value in the expression. T is equal to 100 is equal to A into 20 square plus B. So it will be 400A plus B is equal to 100. That is equation number 2. From equation number 1 and 2, can you solve A and B? From the equation 1 and 2, can you solve A and B? Yes, can you guys find out A and B? B can be written as, from here B can be written as minus 25A. Put the value here, B is equal to minus 25A. So 400A minus 25A is equal to 100. What is the value of A? 400 minus 25, 375. 100 upon 375. 4 upon 15. The value of A will be 4 upon 15. And what will be the value of B? B is equal to minus 25 into 4 by 15. The value of B will come out to be minus 20 by 3. Minus 20 by 3. So these will be the value of A and B. These will be the value of A and B. So our expression will be T is equal to A. The value of A is 4 by 15 X square plus B is equal to minus 20 by 3. This will be our expression. So at X is equal to 15 centimeter, what is the value of temperature? Put the value of X is equal to 15. 4 by 15 into 15 square minus 20 by 3. 115, 15 will be getting cancelled out. The value of T will come out to be, what is 60 minus 20 by 3. How much is that? 180 minus 20 by 3. So 160 by 3 degrees Celsius. How much is that? 160 by 3? 53.33. Isn't it 53.33 degrees Celsius? So this is how the question will be solved. Option D is the right answer. Pradeep, please check. It is option D, 53.33. Yes, Maniket, well done. I hope you guys have understood this question. Is this clear? The next one, question number 2. Let us solve question number 2. Air, the fluid is air at 10 bar. The pressure of air is 10 bar and 400 Kelvin. Temperature is 400 Kelvin, is flowing with a velocity of 20 meter per second. The velocity of flow is 20 meter per second through a pipe of uniform cross-sectional area of 20 centimeter square. Air is flowing from a pipe of constant cross-sectional area, that is 20 centimeter square. The mass flow rate of air in the pipe is approximately, the question is to find out the mass flow rate of air. What is the mass flow rate of air? The mass per unit time. We can call it as mass per unit time, that is mass flow rate, or mass is equal to density into volume per unit time, and volume per unit time is discharge. So mass flow rate of air is equal to rho into Q, and discharge is equal to area into velocity. Rho A into velocity will be the expression for mass flow rate. Yes, please do solve and let me know. Everyone, please give it a try and let me know the answer. Mass flow rate of air is density into area into velocity. Density into area into velocity. The question is a mix of fluid mechanics as well as thermal engineering. This question is a mix of fluid mechanics as well as thermal engineering, isn't it? Because air can be treated as an ideal gas. What is the density of air? We do not know. So from an ideal gas equation, P is equal to rho RT, or we can say rho of air is equal to pressure of air upon R into T. That is how we get the value of. So mass flow rate of air will be equal to density of air P upon RT into area into velocity. Put all the parameter in their SI unit. 10 bar means 10 into 10 to the power 5 Pascal upon R. R is equal to, R for air is 287 into T is 400 into area 20 centimeter square. So convert it into meter, 10 to the power minus 4 into velocity, that is 20. That will be the answer in kg per second. This will be the answer in kg per second. Can you solve it and let me know the answer? These two will get cancelled out with this 400. So it will be 10 to the power 6, 10 to the power minus 4. So 100 upon 287 kg per second will be the answer. What is 100 upon 287? 0.348. .35 is nearly equal to 0.35, isn't it? 0.348 will be the answer to question number 2. I hope this is clear. D नहीं है, D कैसे? Right option है तो 0.35. It will be 0.35. Please check your calculation. Please check your units. Units are very, very important. Units are very, very important. If you will put all the given parameters in their SI unit, then you will be getting the unknown to be in its SI unit. Otherwise, you will get confused with the units and dimensions. So always make it a habit that try to use the parameters in their SI unit only. Bar will be converted into Pascal. Pascal is SI unit of pressure. 1 bar is 10 to the power 5 Pascal. So 10 bar is 10 into 10 to the power 5 Pascal. The value of R for air, specific gas constant, 287 joule per kg Kelvin. Don't use 0.287 because 0.287 is in kilojoule per kg Kelvin. In terms of joule per kg Kelvin, it will be 287. Right? Is this all clear? Please guys, do not forget to like and share this session so that the session reaches to all your friends, colleagues who are going to appear for GATE 2024. The question number 3 on the screen. Next question. Question number 3. Try to solve it. The condition of steam at inlet and exit of a perfectly insulated steam turbine. There is a steam turbine. This is inlet, let me call it as point 1. This is exit, let me call it as point 2. This is the turbine. The condition of steam at inlet and exit of a perfectly insulated. What is the meaning of perfectly insulated? When the system is perfectly insulated, it means Q will be equal to 0. There is no heat transfer. Q will be 0. Q will be 0. वाह किरण, किरण आपकी स्पीड अच्छी है. गुड गुड, वेल डन. रनिंग अंडर स्टेडी स्टेट कंडीशंस. It is running under steady state condition. What does that mean? Steady state condition, mass flow rate remains constant and there is no energy storage. At inlet, specific enthalpy, that is H1 is equal to 3230. Velocity, that is C1, is 160 meter per second. At the exit, that is 0.2, H2 is given as 2660 and velocity is C2, that is 100 meter per second. Neglecting changes in potential energy, the work done by the steam turbine is approximately. The question is from the steady flow energy equation or the first law of thermodynamics for a steady state system. That is the first law of thermodynamics for steady flow device. So H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W. The expression is per unit mass. Each and every term is having the unit joule or kilojoule per kg. Kilojoule per kg or joule per kg. But whenever you are having the potential energy change is negligible, Q is equal to 0. Whenever you are having the velocity along with H, so either put H in terms of joule per kg, otherwise convert this into kilojoule per kg. So let me write it as joule per kg. As I said, try to use all the given parameter in their SI unit. So from here we can say work done by the turbine, work is developed by the turbine. So W is equal to H1 minus H2 plus C1 square by 2 minus C2 square by 2. That is joule per kg. Options are in kilojoule per kg. So we will find out in later, we will convert it into kilojoule per kg. So H1 is 3230 minus H2 is 2660 into 10 to the power 3 plus 1 by 2 C1 square minus C2 square, 160 square minus 100 square. That will be joule per kg. If you want to convert it into kilojoule per kg, divide by 10 to the power 3. So it will be 3230 minus 2660 plus 1 upon 2000 into 160 square minus 100 square. That will be in kilojoule per kg. This will give you the answer in kilojoule per kg. The work produced or the specific work to be produced. Can you solve it? Can you guys solve it? 3230 minus 2660 570 plus 160 square, that will be 1 upon 2000, 160 plus 100, that is 260 into 160 minus 100, that is 60. 1 1 1 1. So it will be 26 into 6 by 20. 26 into 6 divided by 20. 7.8. So 570 plus 7.8, it is equal to 577.8 kilojoule per kg will be the answer. 577.8. Very nice. Pradeep, Maniket, well done guys. 577.8. It is approximately 578 kilojoule per kg. अगर किसी को भी कोई कंफ्यूजन है, if anybody is having any doubt, please do let me know. Please Be open to ask me your doubts. I will be more than happy to repeat again if you face any difficulty. Why I have divided by 1000 here? Why I have taken 2000 instead of 2? Because we want to convert it into kilojoule per kg. Our options are in kilojoule per kg. It is kg. The options are in kilojoule per kg, right? All right then. Let us proceed further. Very, very simple question. I will not be going to solve this one. What is the answer to question number 4? Question number 4 on your screen. Please do let me know the answer. It is very simple question. The thermal efficiency of a reversible heat engine operating between two thermal reservoirs is eta max. Yes, TPM, well done. The coefficient of performance of a reversible refrigeration cycle operating between the same two reservoirs is. What you need to know is COP for a heat pump is equal to COP for a refrigerator plus 1, and COP of a heat pump is equal to 1 upon thermal efficiency of an engine is equal to COP for refrigerator plus 1. And what is the thermal efficiency of an engine? That is eta max. So 1 upon eta max is equal to COP for refrigerator plus 1. So COP for the refrigerator is equal to 1 upon eta max minus 1. Very simple. These are the two expressions you need to understand. One is COP of a heat pump is 1 plus COP for a refrigerator, and COP of a heat pump is the reciprocal of thermal efficiency of the engine working between the same reservoirs. A will be the correct answer. Yes. Well done, Kiran. TPM, Maniket, A will be the right answer. Let us move to question number 5. Question number 5. The question is to find out the COP. It means it is a work consuming cycle. COP is used for a work consuming cycle like a refrigeration or air conditioning cycle, and thermal efficiency is used for the performance of a work producing cycle. So the question is, from a vapor compression refrigeration cycle, an ideal vapor compression refrigeration cycle uses R134A as the working fluid. Alright, the condenser pressure is 5 bar and evaporator pressure is 60 kilopascal. 1 bar is equal to 100 kilopascal. So we can convert it into 0.6 bar. 60 kilopascal is 0.6 bar, isn't it? The refrigerant enters the compressor as saturated vapor and it is specific enthalpy. Can you draw TS curve for a VC cycle? How many of you are able to draw TS curve, temperature versus entropy curve, for a VC cycle? Yes or no? It is anti-clockwise cycle. Work consuming cycle is anti-clockwise. This is isentropic compression. This is point 1. The refrigerant enters the compressor as saturated vapor. Point 1 is saturated vapor. And its specific enthalpy at the compressor exit is this. So this is point 2 compressor exit. So this is H2. I hope this is clear. H2 specific enthalpy at the exit of the compressor is 267.98. The other relevant data regarding 134A are given below. 2 to 3 is heat rejection and 3 to 4 is throttling. 3 to 4 is throttling and 4 to 1 is heat addition. This is, let us say, Q2. This is the storage space, and 3 to 4 is isenthalpic. This is the vapor compression refrigeration cycle. So corresponding to 0.6 bar, that is here the pressure is 5 bar condenser pressure and evaporator pressure is 0.6 bar, isn't it? Now the COP of the cycle, this is work isentropic compression, compressor work, and this is desired effect, this is storage space. So Q2 COP is equal to Q2 upon WC. What is Q2? H1 minus H4 upon H2 minus H1, isn't it? This will be the expression for COP. Desired effect upon work input, H1 minus H4 upon. So what is the value of H1? H2 is given, H2 is known. What is H1? It is simple. H1 will be equal to saturated vapor corresponding to 0.6 bar. This is H1, 224.72. And what is H4? H4 is equal to H3. H4 is equal to H3 because 3 to 4 is isenthalpic, and H3 is equal to saturated liquid corresponding to 5 bar, 71.33. That is H3 is equal to H4. So H1 will be equal to, this is H1 and this is H3 is equal to H4, and COP is given by H1 minus H4 upon H2 minus H1, isn't it? H1 is 224.72 minus H2 is already given to us, 267.98. Sorry, H4 71.33 upon H2, that is given as 267.98, 267.98 minus H1, that is 224.72. That will be the COP. Can you solve it? Can you guys solve it? We do not require the entropy values. We do not need the entropy values. How much is that? Are you getting it as around 3.55? Are you guys getting it as 3.55? 3.54, 3.55 something? COP can be greater than 1. The thermal efficiency of a work producing cycle cannot be more than 1, but COP for a work consuming cycle can be greater than 1. Right? It can be less than 1, it can be greater than 1. So the correct answer is option B for question number 5. Question number 6 and 7 are common data question. Question number 6 and 7. Try to read the question and solve it. This is very beautiful question. Yes, try to understand the given data. A steam power plant which is operating on an ideal Rankine cycle. It is a work producing cycle, power plant engineering. Can you draw a Rankine cycle on TS curve? Rankine cycle on TS diagram. On TS curve, Rankine cycle, how to draw the Rankine cycle? It is clockwise cycle. Clockwise cycle. But for a Rankine cycle, point 1 is inlet to the turbine. We generally use inlet to the turbine as point 1. So 1 to 2 is expansion, isentropic expansion. And then constant pressure heat rejection. Then there is a pump. This is how 1, 2. Then there is a heat rejection Q2. This is 3. this is 4. There is a pump work, there is a turbine work output, and this is Q1. This is the representation of Rankine cycle on TS curve. A steam power plant operates between Rankine cycle operates between pressure of 5 megapascal and 10 kilopascal. This is 5 megapascal and this is 10 kilopascal. 10 kilopascal is the condenser pressure and 5 megapascal is the boiler pressure. Water enters the pump at a specific enthalpy of 191.83. So it is 0.3. H3 is given as 191.83 kilojoule per kg and a specific volume, that is V3. 0.3 is the inlet to the compressor, inlet to the pump, and steam enters the turbine at an enthalpy of, entry to the turbine is 0.1, that is H1. 4612.2 and leaves the turbine as a saturated vapor at 10 kilopascal. The enthalpy of vaporization of water at 10 kilopascal. What is the enthalpy of vaporization of water at 10 kilopascal? That is H2 minus H3 is 2392.8. H2 minus H3 is 2392.8 kilojoule per kg. The question is to find out the net work done per cycle is approximately. So what we need to do is net work done per cycle. So net work is equal to turbine work minus pump work, isn't it? Turbine work minus pump work. What is turbine work? That is equal to H1 minus H2. H1 minus H2. H1 is known, H2 is unknown. H1 is known to us, H2 is unknown, H3 is known. So H2 can be calculated from here. Let us first calculate all the specific enthalpy at each and every point. Can we say H2 minus H3 is equal to 2392.8 kilojoule per kg? Then what is H2? That is H3 plus 2392.8. So H2 will be equal to, H3 is equal to 191.83 plus 2392.8. What will be the value? 191.83 plus 2392.8. 2584.63, isn't it? H2 will be equal to 2584.63 kilojoule per kg. The value of H2 will be 2584.63 kilojoule per kg. That is H4 and H2. And how to calculate H4? Do we require H4? So H1 minus H2 will be equal to, H1 is 4612.2, 4612.2 minus 2584.63, 2584.63. That is the turbine work, kilojoule per kg, WT. The turbine work will be equal to 4612. If you know any other simple method, then please do share. It will be 2027.57. The turbine work will be equal to 2027.57 kilojoule per kg. That is the turbine work. What is the pump work? Pump work will be equal to H4 minus H3. H4 minus H3, or we can call it as V3 into P4 minus P3, isn't it? Because turbine pump is a open system. Pump is an open system, so pump work is given by integration of VdP. Integration of VdP. For an open system, work is integration of VdP. So pump work will be equal to V3 is equal to 0.00101. 0.00101 into P4 minus P3. If you want to have it in kilojoule, then 5 megapascal, if you convert it into kilopascal, that will be 5,000 and 10 kilopascal. So it will be 5,000 minus 10. What will be the pump work in kilojoule per kg? Put the values in pressure in kilopascal, volume is in meter cube, then you will get it as kilojoule. 4990 multiplied by 0.00101, that will be 5.0399 kilojoule per kg. Do you guys understand it? This is the pump work, and the net work will be equal to turbine work minus pump work, that is 2027.57 minus 5.0399. That will give you the answer, kilojoule per kg. The net work is work output minus work input, 2027.57 minus answer. So it will be 2022.53. That will be 2022.53 kilojoule per kg. 2022.53. 2022.53. It is very much close to option A. This will be very much close to option A. Well done, Pradeep. Good, good, good. Shiva, आपने कैसे किया? How did you find out so soon? Is there any other shortcut? Please share if you have any other shortcut to find the net work done. So what we can do is we can calculate the work developed by the turbine, and we can calculate the work consumed by the pump, and subtraction of these two will give you the net work output, isn't it? Let us move to the next part. The thermal efficiency of the cycle is, what is the thermal efficiency of the cycle? That is W net upon heat supplied. W net we have already calculated. Find out heat supplied Q1. Q1 is equal to H1 minus H4. H1 minus H4. We don't know H4, isn't it? We don't know H4, but yes, we can get the value of H4 from here. We can say WP, that is 5.0399, is equal to H4 minus H3. So we can find out H4 from here. H4 is equal to, what will be the value of H4? H4 is equal to H3. H3 is known to us. H3 is equal to 191.83. 191.83 plus 5.0399. So H4 will be equal to 191.83 plus 5.0399. 196.87. 196.87 kilojoule per kg. That is H4. H4 will be equal to 196. So thermal efficiency is given by, the thermal efficiency will be given by W net is how much? That is 2022.53. 2022.53 divide by H1 minus H4. And what is the value of H1? H1 is equal to 4612.2. 4612.2 minus H4, that is 196.87. 196.87. बताइए, what do you get? 4612.2 minus this. So it will be 2022.53 divided by 4415.33. 2022.53 divided by this 0.45807. 0.45807, or we can say in terms of percentage, 45.807%. that will be the thermal efficiency. 45.807. 45.807. C will be the correct answer. C will be the answer. I hope this is clear. Question 6 and 7. Are they clear to everyone? Then the next. Question number 8 and 9. This is how the questions are going to be asked. If you are able to solve these. हाँ मनिकेत कुछ पूछा आपने? सेम प्रोसेस ही होगा. Is there any doubt, Maniket? At the beginning of compression process of an air standard Otto cycle. In Otto cycle there is no phase change. It is the working fluid is air. So what is Otto cycle? There are two isentropic process and two constant volume process. It is constant volume cycle. So if you draw TS curve for an Otto cycle, 1 to 2 is isentropic compression, then 1 to 2 isentropic compression, this is constant volume, heat addition Q1, 2 to 3, then isentropic expansion 3 to 4, and 4 to 1 is heat rejection. This is also constant volume. This is V2, this is V1. So at the beginning of compression process of an air standard Otto cycle, pressure, temperature and volume are 1 bar, P1 is equal to 1 bar, T1 is equal to 298 and V1 is equal to 400 centimeter cube. Right? The compression ratio is 8. What is compression ratio? R. That is equal to V2 by V1. Compression ratio is V2 by V1. That is equal to R. Is it V2 by V1 or V1 by V2? V1 by V2. That is the compression ratio. The maximum temperature in the cycle. This is the maximum temperature T3. The heat transferred during the heat addition process is approximately, this is Q1. The question is to find out Q1, heat transfer. So Q1 is equal to M into CV into T3 minus T2, isn't it? That is Q1. Mass into CV into, the question is the answer to be in kilojoule. M into CV into T3 minus T2. T3 is known. How to find out T2? Can we say T2 by T1 is equal to T3 by T4 is equal to R to the power gamma minus 1? So from here we can find out T2. T2 is equal to T1 into R to the power 1.4 minus 1. Gamma for air is 1.4. The value of T1 is 290 into R is equal to 8 to the power 0.4. So what is the value of T2? First of all, find out the value of T2. T2 is equal to 8 to the power 0.4 into 290. 666.245. 666.245 Kelvin. That is the value of T2. So first of all, find out the value of T2. Yes. And then CV is known, CV for air, that is 0.718. What is the mass of air? Now also find out the mass. Mass is equal to, because air is treated as an ideal gas, air will be an ideal gas, PV is equal to mRT. So mass is equal to P into V by RT. Pressure into volume. Put the parameters in their SI unit. 1 bar is 10 to the power 5 Pascal. Into volume 400 centimeter cube. So 400 into centimeter cube 10 to the power minus 6 upon R, that is 287 into temperature, that is 290. If you put all the parameter in their SI unit, then you will get kilogram. What is the value of M in kilogram? So it will be 40 upon 287 into 290 kilogram. What is the value of M? 4 divided by 287 into 29. 4.806. 4.806 into 10 to the power minus 4 kilogram. Put in equation number 1. So Q1 is equal to 4.806 into 10 to the power minus 4 into CV, because we want the answer in kilojoule. Now we can use CV in kilojoule per kg Kelvin. That is equal to 0.718 into T3 minus T2. T3 minus T2. T3 is 2200 minus 666.245. Can you get me the answer for this? Can you find out the value of Q1? 4.8 into 10 to the power minus 4. मनिकेत, यूनिट में बहुत कंफ्यूजन होता है स्टूडेंट्स को. सो टू अवॉइड द कंफ्यूजन इन यूनिट्स, प्लीज ट्राई टू यूज द यूनिट्स इन देयर एसआई यूनिट. प्लीज यूज द parameters in the SI unit, because we want it in kilojoule. That is why I have taken CV in kilojoule per kg Kelvin. This is Kelvin, this is kilogram. So that is why we will get kilojoule. Can you solve it? Into 0.718 into 2200 minus 666.245. 0.529 kilojoule will be the answer, isn't it? क्या आ रहा है, सही है क्या? 0.529. D will be the answer. D will be the answer. 0.53 something. D will be the correct answer. Are you getting it or not? D will be the answer. Right? The next part, the thermal efficiency of the cycle. The thermal efficiency of the Otto cycle is equal to 1 minus 1 upon R to the power gamma minus 1, isn't it? So we can directly calculate 1 upon R, that is 8 to the power 0.4. That will be the thermal efficiency of Otto cycle. What will be the thermal efficiency? 8 to the power 0.4. 1 divided by this. 1 minus answer. 0.5647 or 56.47%. 56.47%. The answer to this one was also D. Otto cycle thermal efficiency. One more question. This is linked answer type question. Question 10 and 11. Now try to solve this one, everybody. An ideal gas undergoes a cyclic process. This is given, PV diagram is given for a cyclic process consisting of the following three processes. It is three processes thermodynamic cycle. Process 1 to 2, compression process with PV is equal to constant. What does that mean? It means temperature is constant. Isothermal compression. Compression process with PV is equal to constant means isothermal compression. It is isothermal compression. T is equal to constant. 2 to 3 is constant pressure. It is constant pressure heat addition. Constant pressure, 2 to 3, pressure is constant. And 3 to 1 is constant volume, heat rejection. Constant volume heat rejection. And U3 minus this is constant volume process. So there are three processes. One is isochoric, isobaric and isothermal. So 3 to 1 is isochoric, U3 minus U1. The change in internal energy is 3549. change in kinetic and potential energy are neglected. The work done during the process 2 to 3 is, what will be the work done? Work done by a process is area under PV curve. So this will be the work done. Area under PV curve projected on volume axis, that will be the work done. Area under PV curve which is projected on volume axis. So can we say this is P2, let us say, this is P1. So it will be P2 into V3 minus V2, isn't it? This is W2 to 3. P2 into V3 minus V2. V3 is known to us, this is V2. V3 is known, V2 is known to us. The problem is with P2. So because 1 to 2 is constant temperature process, so can we say P1 V1 is equal to P2 V2? Or can you find out P2 is equal to P1 V1 upon V2? What is P1? That is 1 bar into V1. V1 is equal to V3. V1 is equal to V3. That is 1.6 upon V2, that is 0.2. What is the value of P2? So the value of P2 will be equal to, the value of P2 will be 1.6 divided by 0.2. 8 bar. The value of P2 will be 8 bar. Then the question is to find out the work done during the process 2 to 3 in kilojoule. So P2 in kilopascal will be equal to 800, isn't it? It will be 800 kilopascal. So if you put the value W2 to 3 is equal to P2 into V3 minus V2. P2 is 800 kilopascal, V3 is 1.6 minus 0.2, that will be kilojoule. 800 into 0.8. Sorry, 1.4. 1.6 minus 0.2 is 1.4 kilojoule. So work 2 to 3 is equal to, how much is that? 1120 kilojoule. It will be 1120 kilojoule. The option A is the correct answer. Option A will be the right answer. Isn't it? Option A will be the correct answer. The second part of the question, the data is same. The heat transferred during the process 2 to 3. There is a heat addition during the process 2 to 3. How much will be the heat transfer? So if we apply first law of thermodynamics for the process 2 to 3, for the process 2 to 3, if we apply the first law, then can we say Q2 to 3 is equal to delta U 2 to 3 plus W2 to 3, isn't it? This is Q2 to 3. Delta U2 to 3 plus W2 to 3. W2 to 3 we have already calculated. So we can say Q2 to 3 is equal to U3 minus U2 plus W2 to 3. And W is equal to 1120. Now we know U3 minus U1 to be given. U3 minus U1 to be given. U3 minus U1 is given as 3549 kilojoule. Now because 1 to 2 is constant temperature process, for 1 to 2 constant temperature, and for an ideal gas U is a function of temperature only. So can we say U1 is equal to U2? So this can be written as U3 minus U1 can be written as U2. So U3 minus U2 is equal to 3549 kilojoule. Put in above equation Q2 to 3 is equal to U3 minus U2, that is equal to this plus W223. Put the values 3549 plus W is equal to 1120 kilojoule will be the answer, plus 3549 4669 kilojoule will be the value of Q223. 4669. D will be the right answer for this question as well. So please do like and share this session. I hope you guys have enjoyed it. Yes? Were you able to revise some of the fundamentals related to the thermal engineering? We have discussed one question from the Otto cycle. We have discussed one question from the Rankine cycle, power plant engineering. We have discussed one question from the refrigeration cycle, VC cycle as well. And from the basic first law of thermodynamics for a closed system. This is the first law of thermodynamics for a closed system. This question is from the closed system. And we have discussed one question from the open system also, steady flow energy equation. If you are not able to solve these questions, we have discussed the general formula also. If you are not able to understand, we have discussed one question from the zeroth law also. So most of the topics have been covered through these 10 or 11 questions. So please try to solve these questions again. I will share the PDF of this session to my Telegram channel, right? And try to improve your preparation, try to revise as much as possible, try to practice as many numericals as possible. Please appear for the mock test. There will be a scholarship test on 3rd of December. So do appear in the scholarship test. The registration is completely free. Based on your performance in the scholarship test, you can get the discount or the scholarship up to 90% in our various paid courses. And do not forget, if you are appearing, if you are a candidate for GATE 2025 on 6th of December, that is on Wednesday, there is an important workshop which is conducted by Abhinav Negi sir. He will be guiding you how to clear or how to become the topper in GATE 2025 with some basic and fundamental rules to be followed during your preparation. The link to join these is already there in the description box. And one more important information, we are running All India Open mock test, All India Open Mega Mock Test or Mega Mock Challenge, MMCs. I hope you guys are participating in these tests. They are for GATE 2024 aspirants. So this 4th subject-wise test will be over by 1st of December, tomorrow. If you have not attempted this test, please do appear for the test. The syllabus for this test is already given and the result will be announced on 2nd of December, and then there will be full length test. This is the entire schedule for MMC. Based on your performance in these tests, you can unlock our test series also for the discounted prices. Link is already there in the description box. We are running some paid courses for GATE 2024 as well as 2025 and 2026. If you are interested to be part of our paid courses, you can connect with our counselor to know more about the paid courses. We are providing you these many benefits if you join us for the paid courses. All right, and there is a bit.ly link also. If you are not part of if you have not installed, downloaded our BYJU'S exam prep app, because there are practice sessions for ISRO. As you all know, ISRO is a golden opportunity and the examination is going to be conducted on 17th of December. For ISRO, there are practice quizzes on BYJU'S app. So download the BYJU'S app. There is a bit.ly link in the description box. Do go through the bit.ly link to download the BYJU'S app and start practicing some numericals related to ISRO if you are going to appear for this examination on 17th of December. So that is all from my side, guys. I hope you have enjoyed and you were able to revise your basics for the thermal engineering. See you in the next session. Till then, enjoy, take care, have a good day and a great career ahead. Thank you and Jai Hind.